Welcome everyone to Robot Builders Night Virtual for June 24th, 2025. And we've got DPRG news, we've got a queue going, and then we'll move to open mic. So DPRG news, we've got the visit to Robot Lab this Saturday at 10 a.m. I know Scott, I've got RSVPs from Scott and Kareem, and I don't think you're coming to that, right, Ray?
Yeah, I have an RSVP. There was a thing, my wife and I volunteered a food pantry, and they set up just an appreciation lunch the same day before Robot Lab was set up. So I'm going to still try to come. Do you still only have 5 people?
It's gotten expanded a bit since I sent out that email. But if you can make it, if you can send me a note like as late as the night before, that'd be great.
Okay.
Just so I can, let our host know about how many.
Oops. You froze.
Hadn't seen RSVP from you, so I assume you're not coming.
You froze for a second there, Paul. I didn't hear what you said.
So I was talking to David Blue Steel about whether he's coming to the Robot Lab visit. Just trying to get my head count right.
Yeah, unfortunately, I can't make it.
Yep. So that's it for DPRG news.
Question. I have a friend that might want to come to this. Is it open to other than DPRG people?
Yeah, that's okay. There's a couple people that are bringing extra folks. So Dave, I'll put you down for 2.
Okay.
Paul, do you know if they feature any I don't know, like 4-wheel drive agricultural type robots, or do they have?
They do agricultural robots, but I don't know if they have any there. It's sort of like they're sort of organized. So let me just share, because I'm going to share anyway. They're organized around
maybe restaurant use and things like that.
Yeah. Where am I? Here we go.
The combines just wouldn't fit in the showroom.
I just need a weed picker and a poison ivy mower and a anti-chigger device. Let it try to attack the robot and bite it.
So these are the areas of that they support, but really their main focus, I think. Well, I don't know that much about them, but my impression is their main focus is on warehouse.
Yeah, materials management kind of stuff.
Yeah, mobile robots, greeter bots. So that's that would be like retail, and see what I really want to do is robotlab.com. There we go. Here we go. So they advertise agriculture, but cleaning is another one, which it's like, so delivery and cleaning. I told Meshva that as a group we're really focused on mobile robots. So that's pretty much delivery, cleaning, maybe disinfection. I doubt we're going to see any mobile tractors.
It could be small.
So they represent the company that spoke to us, Kabam Robotics,
Yeah.
that spoke to us beginning of last year. So memory care. So one of Carl's colleagues in his business is going to come and ask some questions about memory care. So yeah, so that
sounds like agricultural is not a focus for them then, right?
I haven't heard them talk about that.
Yeah.
And you click on those links and they take you to like pictures of the robots that they support.
Right.
So if that's your only interest, then it might not be all that interesting. But I just think it'd be fun and interesting to see a whole range of different robots that'll do different things and learn about what sensors they have. There'll be a couple of them that will be live and we'll be able to experience them. And then my understanding is there'll be a bunch that will be just sort of powered off, but we can look at them and maybe talk about them, ask questions. But they only have a limited number of people that are going to be there what do they call them, SMEs, subject matter experts on each robot, and so they're not opening up the whole facility and fully staffed and everything for us. Okay, with that, I'm going to move on to the queue, and so I'm going to share. Well, I've got one thing to go over here, and then I've got something for open mic. I finally got the robot hardware talking to Ross, but anyway, there's a group that meets on Sunday afternoon that's interested in Linrobot, and as I've talked about before, I've been working on Linrobot. I got some pull requests accepted that got it to work, got hardware to work on Jazzy, on Ross Jazzy, and so the architecture of Linrobot is you got a robot computer that runs all the ROS nodes, possibly multiple robot computers, runs the nav stack and EKF and a few other nodes. Then you've got a microcontroller that runs microROS, and it runs the low-level real-time stuff like the motor driver and encoder driver and IMU driver, and those two can talk via serial or over Wi-Fi, over UDP. And so what I want to explain is the guy who leads this Sunday meeting group, French guy, has been hot on Zenoh Pico and intends to port it to Linrobot. So I was like, okay, what is Zenoh and this Zenoh Pico? So I just got a couple of slides here to share on what that is, and to understand what it is, you kind of need to understand how ROS relates to microROS. So if you think about the architecture of Linrobot, which is ROS and microROS enabled, where ROS runs on the robot computer running Linux and microROS runs on the microcontroller, that does all the low-level stuff. Well, the software architecture of that is that you've got in ROS, you've got the user code that runs in the application layer. That's the stuff that we write, the nodes that are written in C++ or Python, and they make calls into the ROS2 client layer to the RCL CPP library or the RCL Pi library, which if you've written any Python nodes, you're hashing, you include, or you say from RCL or import RCL Pi. Those are really just shims that adapt to the ROS2 client library, which is in C, that takes the things that the user code asks for, like create a subscription, create a publisher, create a service client, and turns them into requests to the ROS middleware layer. RMW is the ROS middleware interface that serves as another shim that adapts that request to three of the supported DDS implementations, and the default one that ships with ROS is Fast DDS from eProsima. And so DDS is a packet transport protocol that takes these requests from the ROS middleware interface to create subscribers and publishers, and converts it into the appropriate DDS interface for whatever DDS flavor you're using, which then calls down into the operating system to make socket calls, UDP or UDP socket calls to do the discovery and advertise the publishers and tell other publishers about the subscribers and all that stuff that happens inside of DDS. So that's ROS that runs on your robot computer. Then MicroROS that runs on your microcontroller has a very comparable stack where you've got application components that like your motor driver software and your IMU driver and your odometry driver that talks to the hardware, and it creates subscribers and publishers by making calls to the ROS API in the C language. Now this API in the light blue color is actually the exact same code as is over here on the ROS2 client library. So it's a C implementation that lets you create subscribers. And so by being the same code, not just intended to be the same or compatible, but the actual exact same code, it is bug for bug compatible with the ROS2 client library running on your ROS computer. And so on MicroROS, this library calls down into the ROS middleware, which is also the exact same code that you find on the robot computer. And then instead of one of these supported DDS implementations, below that you have a micro DDS client, which takes these DDS requests, ships them across the network, either over serial link or over Ethernet or Wi-Fi, to an agent running on your robot computer, and that plugs into the ROS2 stack somewhere around this DDS implementation layer. So packet requests that come in from firmware components like an odometry app publishing the odometry message come down through the ROS middleware, through the DDS client, out into this sort of DDS layer where they can go around the network to other computers potentially that are monitoring this stuff. So that's how ROS to the architecture running on your robot computer on Linux, and MicroROS running on your microcontroller relate to each other. So it's a parallel stack, some of it using the exact same code. So now the question arises, what is Zenoh and where does Zenoh fit into this? Well, DDS, as you may have heard many people grumble, is an awful, awful, awful disaster in the ROS world. It's caused me more pain and everybody more pain than it ever should have. Absolute mistake by architects. But anyway, it is what it is. Zenoh gets plugged in place of this DDS implementation layer. So it plugs in as an alternate transport, replacing DDS and talking to Linux and Windows and the layers below that to talk over the network. And the stuff above stays the same. So on the microcontroller, so there's two pieces. So just as there's two pieces to there's two pieces to all of this stuff. There's back in the Linrobot world, there's a Linrobot 2 repo that contains all of the raw stuff. There's a Linrobot 2 hardware component that gets built into something you can a piece of firmware that you can install on an ESP32 or a Pico. And similarly, in the ROS and micro-ROS architecture, you've got two pieces, the stuff that runs on a ROS computer on Linux or Windows, and the part that runs on a microcontroller running on top of, in an Arduino environment or on top of an RTOS, but basically in on-the-metal, real-time kind of environment. Zenoh plugs in place where you see DDS. So what is Zenoh? It's a publish subscribe message passing protocol similar to MQTT. MQTT is pub sub only, and Zenoh adds network storage and network compute via RPC calls that are baked into the protocol. So it's well suited for ROS's service client, service server capabilities that really ROS really depends on. Zenoh is an acronym of Zero Network Overhead, which actually means there's actually 4 bytes of overhead on the wire. So, but basically it's a really low overhead packet passing protocol. Not, somewhat along the line. I mean, that's what DDS is, right? DDS passes packets around to publishers, between publishers and subscribers on the network, which can be on different computers. And that's what MQTT does. It's what Zenoh does. So these are all packet passing protocols, and Zenoh is just another one. Zenoh is charted under the Eclipse Foundation. But if we look at the particularly if we look at the Zenoh architecture, the RMW, so the ROS middleware Zenoh architecture, there's 2 pieces of it, just like we saw before, one that runs on the robot computer and one that runs on your microcontroller. And so ROS middleware Zenoh, you've got the ROS app like we saw before, the RLCPP library. Then you get down to where it starts to differ, RMW Zenoh and Zenoh underneath that. So referring back to the architecture in ROS, here's your RMW Zenoh plugs in there, and then Zenoh plugs in there. And on the microcontroller side, you've got the same ROS apps that run your odometry calling into the ROS C library. You've got the RMW Zenoh Pico and Zenoh Pico that replaces this DDS stuff in the dark blue color and talks across some kind of interface back into Zenoh at this transport layer, and then it all goes around the network and can talk to multiple computers. so that was my big discovery. So I'm open to any questions anyone may have at this point. But I took a dive down into Zenoh and what does it mean. And the reason I'm real interested in Zenoh and the guy who leads the Sunday meetup is interested in Zenoh is DDS is such a disaster. And I've spent the last 6 months, wasted days and days and days on it, and just got it working, finally working today with the help of one of my buddies. But it's a disaster. And so Zenoh is much easier to get going, primarily because it doesn't depend on multicast. And multicast just is not reliable on Wi-Fi, and our robots run on Wi-Fi. So basically, this whole DDS implementation layer is problematic for ROS, and Zenoh replaces it. I've had some experience with Zenoh. I submitted some documentation improvements to the project and tested it. Testing resulted in the documentation improvements. So I feel I know what it is, and I've had experience with it, and it just works like it.
I'm sorry.
And so Zenoh Pico is the microcontroller side of that runs on a Raspberry Pi Pico. So the Pico, I thought Pico would just mean like small, like it's a Pico version of Zenoh. It's not. It's actually Zenoh for the Pico, for the Raspberry Pi Pico microcontroller. So say the 2450, I think it is, the RP2450 microcontroller from Raspberry Pi that's in the RPi 2W and its brethren.
Yeah.
That's
the newer one. Yeah.
What's that?
The RP2040 is the original, I think.
Yeah.
2050 is just a little bigger. Yeah.
Right. So Zenoh Pico is for that microcontroller. So you could plug one of those RPis or RPiWs, RPi2s, RPi2Ws in to run this microcontroller code, and it talks across to Zenoh on this is the concept. So that's where we want to take this thing. Does anyone have any comments, questions, thoughts on that?
So what's your big DDS issue? Is it just unreliability on Wi-Fi?
Yeah, 100% unreliable. And I ran into that when I was teaching that ROS intro to ROS class beginning of last year, where some of the attendees couldn't get multiple computers to talk to each other between ROS. Like you can SSH between them and you can ping between them, but you couldn't pass ROS messages between them. And so anyway, that's what DDS is.
Yeah, because I mean, I use the external computer for debugging, like to run RViz or Fire or Foxglove or something, and
Right.
And it's pretty slow or something. It's just not as good as you would want. And for my project, for my Robo Columbus, I've switched to Jazzy, which is Ubuntu 2405, and that's on my Pi 5 now. But my workstation is 2404 with Humble, I guess, and I can't get the DDS doesn't pass between those two operating systems or something because I can run RViz on my Pi 5 and get information, but on my workstation with the different operating system,
Well, if you're running 2404 on both computers, you should be running Jazzy. You should not be running Humble.
Right. But my laptop is 2204. I'm sorry, 2204.
Oh,
Yeah.
2204, and that's why
Yeah.
you're running Humble.
Right.
Yeah,
But I'm just saying that they're not compatible for some reason. I mean, you can see some of the stuff, like you can see topics, but you can't see nodes if you do a node list, and so there's some incompatibility.
You shouldn't try and mix and match ROS versions. You should just go to a Docker instance. If you can't upgrade your laptop, which I get, I understand why. There's a lot of reasons why you might not be able to do that. You should go to a Docker instance and run ROS Jazzy on a 2404 based Docker instance.
Yeah. I'll probably update my laptop, but that was one of the things I ran into. It's like,
that will be a problem. It turns out that my major problem, and Kareem tried to help me, and there's these workarounds that are supposed to work so that you don't depend on multicast, where you declare a server, a DDS server. That wouldn't work. So it turns out that there were at least 3 problems that I was facing. One is my Eero mesh routers don't reliably run multicast. And there is actually a ROS test. Let me see if I can find it. I'm not going to be able to find it here, probably. So anyway, if you go to the ROS install section, there's a if you're having problems, look at this section. Look there, and there's a command I never knew about before: ROS2 multicast receive and ROS2 multicast send. And so you start receive on one computer, you start send on the other, and send just should send in the packet, and it tells you whether it succeeded or not. On my Eero network, it would succeed about 1 time in 10. So that was problem number 1, is ROS DDS discovery wasn't working because the Eero mesh routers don't do multicast properly. And Kareem's got to work around that involving 0-tier, and I didn't implement that properly, so I can't speak to whether that would have fixed my problems. Second problem was when you install Ubuntu 2404, by default the firewall is disabled. It appears based on my experiments with my Raspberry Pi and my laptop. And you would think that if the firewall is disabled, that it would let everything through, but no, it blocks everything. Specifically, well, it doesn't block everything. It doesn't block SSH or ping or SCP or the common thing you use between computers. So I was like, I can talk between the computers. I can ping them. I can SSH into them. They're talking. Well, it turns out that it blocks all UDP traffic, and DDS uses UDP. So as a second issue behind the network not supporting multicast, the Ubuntu firewalls on the laptop and Raspberry Pi did not pass UDP traffic. So that was like, and that's why I tried these workarounds where you declare a discovery server, and they didn't work. And the reason they didn't work is because the firewalls were disabled, and therefore were blocking UDP traffic. So what a disaster. Anyway, that's enough whining from me.
I think you've run into about every problem there could possibly be. You must need to do something to appease the gods.
Yeah. Yeah, and yeah, I did. I've been fighting this for 6 months since I put my new mesh routers in and upgraded to 2404. I have not been able to get my laptop to talk to a Raspberry Pi, and it used to work, and I couldn't figure out why. But I've got an extremely bright buddy who's staying with us at the moment, and we sat down, and in 3 hours we cracked it with the help of Wireshark. So we Wireshark the packets coming in from and we just tried to use Netcat or NC to send a UDP packet between one computer and the other. And Wireshark saw it, but it never echoed on the console. And we were like, oh, Firewall. So we opened up all the ports on UDP, and suddenly it all just worked. And then I switched from my home network Eero mesh network routers to Starlink, and I think I'm actually still on Starlink. Yeah, I'm still on Starlink, and that fixed the multicast issue. Multicast works with the Starlink router, and so I was able to get it actually working. So there you have it, my sad tale of woe, along with I guess some advice to Mike about getting everything on Jazzy. Don't try and run mixed versions, and an explanation of what Zenoh is.
So I have.
Are you saying that Zenoh was working fine under your crappy network configuration?
I can't answer that because I haven't run Zenoh since I changed out the mesh routers.
Since you went to the mesh router, the new mesh routers?
Yeah, since I went to the mesh routers and since I went to 2404, I haven't tried Zenoh, so I can't answer that question.
So
DDS was working before?
DDS was working for me when I was using an Asus router and 20.04.
Got it. Okay, so your frustrations with DDS may be mostly related to your underlying networking problems.
Partly to the networking, yes, exactly, to the underlying networking problems, specifically the mesh routers not supporting or not working reliably with not broadcast, with multicast, and to the new 2404 installs having the firewall disabled, which shut off all the UDP ports.
So Paul, Ubuntu 2404. Since I'm switching to it, I need to go open up those ports to get the best performance.
Yes, and to get it to work at all. And enable the firewall, because if the firewall's disabled, it like shuts off UDP.
Okay.
You know, they seem to be tightening down Ubuntu as they go along, and because it wasn't like that. I never had to mess with the firewall before, but that was a solution we found to make this 2404 install work with ROS nodes between computers.
Okay. Yeah, because I'm going there, so I need to know that. Thank you.
Yeah, and that relates to your saying that hey, you weren't happy with the performance of the NAV2 stack and AVIS on the Raspberry Pi, and yeah, that's what I found too. I tried to run them on my Raspberry Pi 4, and they were pretty sucky. They like barely worked on a Raspberry Pi 4, like lots of drop packets, and didn't update the GUI very well. And but so I think the solution is to run the bring up script that talks over serial on the robot computer. The robot computer is on the robot, and it's a Raspberry Pi. It talks to a serial microcontroller or whatever it talks to bring in odometry and IMU and all that, and then have the nav2 stack and AVIS run off on a laptop or a big computer. Okay, that was all I had. Tom, you had something.
Okay, I'll just share a window here. This one. This is just several little glittery things that might be of some interest. Let's see. Am I presenting? Can you see something?
Yep.
I always get these strange messages that pop up instead of what I'm sharing. So I have no idea what I'm sharing. Show my screen anyway. How's that?
Seeing STM32F412.
Okay, yeah. So as a result of other things, the last few weeks I've been spending more time getting familiar with Marketplace, which I've had to get comfortable with for other reasons. And of course, I couldn't resist the temptation. Normally, I do nothing in Marketplace. Couldn't resist the temptation to wander around and see what's out there. And I ran across this that somebody locally was selling dirt cheap. This is not a bad little STM32 F412, an ARM M4 capable embedded computer. The interesting thing about it is the black connector pinouts here have embedded within them the Arduino Uno pinout, which I thought was kind of neat since I have all kinds of Arduino Uno plug-in boards. And from talking with some other folks who know more about this than I do, this apparently is a hardware debugger interface, which as he says, don't break that off. That's really valuable. So I've tested this thing to make sure it's working, and I've taken a look at some introductory ways to program it. There's a full implementation on the Arduino IDE, which I'm very comfortable with. So I will probably play around with that once this thing rises high enough on my playlist. But I thought you might be interested in that. These are nice little embedded computers at the low end of configurations. Some people in the Ottawa group use them extensively. Now, the other item that came up when I'm browsing Marketplace was this stuff. Some of you may recognize this as early vintage VEX Robotics items. The thing that caught my attention when I first looked at this, the fact that this box full of parts contains 2 claws. The claws, I'll show you this later on when I turn this off, but the claws are the perfect size for a tin can. So I thought that was kind of cool. I have tested all the bits and pieces here. The microcomputer is an ARM M3 equivalent. This is an early VEX Robotics Cortex processor. It's got things like embedded H-bridges and a bunch of other stuff, and it comes with a controller which is wirelessly interfaced to the microcomputer over what VEX calls VEXNet. And all that stuff is working. I've tested it all. Comes with a bag full of 8 different wheels. These are 4-inch wheels. 4 of them are Omni wheels and 4 of them are regular wheels. A bunch of miscellaneous metal parts. There are a total of 8 gear motors with this thing. 5 of them in boxes that have never even been opened. There are 6 H-bridges to go with the motors. There's a 3,000 milliamp hour nickel metal hydride battery pack and a smart fast charger. I've tested them and it runs just like brand new. for those who are into this kind of kit stuff, there's a whole box full of metal screws and nuts and bolts and axles and some limit switches and a bunch of other stuff. So I've played with this thing to get to the point where it actually works. And because I want to do something with it, I cobbled together, I'll show you this later as well. I cobbled together a four-wheel drive chassis and put a platform on the top so I can put the micro and some other things on top. This thing looks pretty impressive. I've never played with any of this stuff before. Those of you that are comfortable with FIRST Robotics implementations will recognize the VEX Robotics system as kind of the next step down from FIRST Robotics. Not nearly as sophisticated a robot implementation, but still, from my readings, incredibly popular and common in use, educationally especially. So I was quite intrigued to be able to add this collection of parts to my collection of stuff. I took a look at the many development environments that have appeared over time that are usable with these things. Not all of them run with the early vintage of the VEX Robotics system. This is known as the VEX IQ system. This was the Robot Claw kit. The VEX Robotics, the mainstream development environment, no longer works with this. A couple of the other things don't work. A couple of them do work. You have to pay for them. So after some experimenting, I settled on a development environment known as Robot C, which seems to work very well. It's not very complex. Think of it in terms of the complexity of the Arduino development environment, which I'm already familiar with. The Robot C has a full complement of libraries to run with this level of technology. So that's kind of fun. The limitations in this system is none of the gear motors have odometry on them. This thing implements I2C for a lot of sensor interfaces, but I don't have any of the sensors. So I'll have to configure my own if I want to use them. Many people have built add-on libraries that run under Robot C. Robot C is interesting in that it's not a compiled C, it's an interpreted C. I've never run into an interpreted C before, but it still seems to be quite functional. The test routines I've run on the computers and the computers work well. So I'm not concerned. I figure if I'm comfortable running MicroPython on 32-bit embedded systems, then running an interpreted C is really not a whole lot different than MicroPython. So this is kind of an intriguing, again, another glittery thing, but it's produced a very nice little platform to play with. Unless you have any questions, I'm going to stop sharing this.
Yeah, so the Robot C was actually written and maintained by a former member of the DPRG, Dick Swan.
Oh, nice.
Yeah, he was a member for many, many years, and I think may actually even still be a member.
Okay.
But he doesn't, appear at all. But
Well,
yeah, he was local here in Dallas for many, many years and wrote Robot C and maintained it.
Well, I like it. It certainly seems to run well. He released it into the public domain about 5 or 6 years ago, I think. But there's still a lot of community activity using it.
Oh.
There tends, from some of the forums I've read, a lot of educational organizations chose this product line as part of their curriculum for STEM-related, robot-related stuff, and didn't really want to move forward as the VEX Robotics environment moved forward. So they just stuck with what they had and with the software they had. Still runs.
Yeah, when he was retiring, he was getting tired of maintaining it and wanted it to go somewhere. I think he had some negotiations with VEX to take it over, but I'm not sure how that all went down. But we used to use it also, so it's been used both by VEX, competitive robotics, and in FTC. We used to use Robot C on the NXT way back in the day.
Kareem, I was very intrigued as I read through forums on VEX Robotics to see there's a lot of movement back and forth from a FIRST Robotics environment to a VEX environment in terms of education, in terms of components, even in terms of the thought process about what a competition should look like.
Yeah, so they were actually in bed together at the very beginning. So VEX the company behind it, they were the FTC, the original FTC partner with First, and there was some sort of fallout, and they went their own way. But that's why they both have the same 18-inch cube starting size for robots, and a 12-foot square field, and 4 robots on a field. That original format evolved when they were partners, and then when they finally separated, First eventually went off and solicited their own control system builds and things like that, and they've been diverting, and you've got more flexibility under First on the kinds of components you can use, but it's still not a fully open system.
Yeah, and First does much more complex challenges in their competitions.
They're somewhat similar, I would say. And there's a lot of very good VEX teams. I would still rank First higher, but maybe that's my own bias from being on that side of the field. But they do some pretty cool things. It's just sad that you have to stick with their build system, because that is definitely limiting.
I had a little chat with the person I bought this kit from, and this was something he actually didn't pick up, but his dad tried to get him interested in it. So, hence, I suspect why some of the boxes aren't even opened. But he acknowledges that he hung on to it in case it looked useful. But he's finished school, and he's been living at home, and his parents are retired, and they're selling the big house, and he's got to get out. So he doesn't have room to take it with him.
Well, if anybody's looking, Carnegie Mellon has a great outreach program where they do a lot of training for kids. And there's a huge curriculum built around Robot C there.
Okay. Any other comments?
You mentioned that you haven't run into any interpreted C before, right?
No, I don't think I have.
Yeah, I mean, it's actually been around for a while. So in the robotics space, some of you might be familiar with the MIT Handy board and the 6270 board.
Yes, I am.
And I forgot the guy who created this stuff at MIT decades ago, but they also created this thing called Interactive C.
Oh, okay. Yeah, all right.
Interactive C used to be what you use with the Handy board and the 6270 board, before Python was a thing. And that was an 8-bit, 68HC11 Motorola microcontroller. And so they had this C interpreter there, doing the bytecode thing. And
okay,
it was quite effective, because you could do a lot of interactive experimentation, read the sensor, type in the command, make a couple changes to your sensor positions, and just kind of do some of the things that we do today with Python interactively, right? Which is sometimes useful. So,
yes.
So the concept's been around for a long time, including in robotics.
I found Robot C interesting when I realized it comes with built-in single stepping, built-in debugging, built-in data logging. It just runs. So far, I haven't done much with it, but it just seems to be there. It'll be nice.
Yeah, just to echo Kareem's comment about the complexity of the challenges being similar in FTC and VEX. Doug and I recently went out and did practice interviews with Trish Cook's VEX team, and so we got to understand the competition, and it was indeed very similar in its goals and the level of difficulty that there was. So you shouldn't the challenges were really similar.
Okay, good.
And really smart kids doing them both.
Okay, I'm gonna turn that off and just show you a couple more other things. There's for what it's worth, there's the can, and it's the grabber. A couple of these came in the box, so I'm quite looking forward to implementing these things so that I can do a little bit more with them. The chassis I put together so far looks like this. This is very, very simple. 2 motors, 4 driven wheels. Very slick assembly practice. I'm not much of a mechanical engineer, but I appreciate it when somebody's done a nice job of putting these things together. The only downside is that all the little dimensions and all the little nuts and bolts and things were clearly designed for much smaller, more flexible fingers than mine. Arthritis gets in the way when you put these things together. I mounted a wooden platform on top because it's a little easier to put stuff on. And I'm very comfortable with that and have a big collection of small screws. So we'll see how that works out when I program it. Now, the other thing that I had mentioned several weeks ago that I was starting to tinker with, I've had an outside security camera system for a long, long time with analog cameras, and they're getting old. They're really showing their age and their lack of resolution. So I decided to implement some power over Ethernet camera capability. So I bought a power over Ethernet bridge to play with several weeks ago, and then ordered some cameras, or ordered a camera to play with. There's one there. These are power over Ethernet 4 megapixel, so they're roughly 8 times the resolution of the cameras I'm used to having on my system. I don't know how far I've got it hooked up to a long wire here for testing, but these are very, very slick. And this camera through AliExpress cost me $26 Canadian, free shipping. Came in 7 days. It's a very, very nice little package. It's highly configurable in a browser. Contains a Linux embedded computer. It also contains enough artificial intelligence capability programmed into it to do things like identify human beings in the field of view. So for $26, that's quite a nice deal. We'll see.
Tom, are you gonna mount that on top of your robot?
I hadn't thought of that, but yeah, why not? It's cheap enough to play with, and it's very low power. The other thing I got at the same time, I have a lot of stuff that's not power over Ethernet, but is Ethernet accessible, like this particular camera. So I bought some, what are these things called? These are called splitters, power over Ethernet splitters. These are about $6 or $7 each, and they break out the Ethernet and the power. I picked this one for 5 volts at 2 amps because that's what this camera has. But as I thought about it, since I bought a couple, the other thing that runs on 5 volts and has an Ethernet port is a Raspberry Pi. So this might make a nifty way to stick a Raspberry Pi at the end of a power over Ethernet cable. We'll see. Anyway, that's all I've got to play with here. I'm really looking forward to upgrading my outside camera system. The resolution improvement, I think, will be substantial. We'll see.
Nice.
Just
Oh, my
delivery stuff, not a robot. Well, one robot. But
Yeah, I like
believe
the
the
little
Raspberry
fixed
Pi-
robot. That's cool.
Yeah, I like the Pi over Ethernet with power over Ethernet, because I know you can get hats for it, but hey, that's a great way to do it if it works. Yeah.
Mike, you're up next.
Okay. Well, I've been working on understanding the ROS Jazzy and getting it installed on the Pi 5, and so I put a complete a desktop on Pi 5. I prefer not to, but because it consumes resources, but I did, and I can VNC into it to get access to graphics like RViz. Though I prefer to run RViz off. I think it's a lot lighter on the communications on the data, but and less load on the Pi 5. So I'll be working on trying to get that Pi 5 and my desktop working together. And so on my so I got the my Oak D Lite camera, and I've been wanting to get it to work on the Raspberry Pi 5. So the examples and stuff weren't quite working good for Ubuntu 24.04. And so I just went to the Ross driver for Jazzy, for the Oak camera. And I got the driver to work and show the camera on RViz, the screen. I haven't got AI on it yet. I said, hey, I'm there. So I moved on. So I just had to move on to a different thing that I need to get done. And that is working on the controller. I mean, the microcontroller under the hood of my car. The ones that hooks up to the ESC motor and the RC transmitter, the controller, and so it sort of fits in the middle of that. And the default mode is for it to power on and everything just passes through. But my original implementation, I used a PCM switch to pass it through, and it worked, except I didn't get any telemetry back. And the one thing that was noticeable was on my, I'm not sure if you can see it very well, but there's like a voltage indicator on here, which is your battery level. And so when I was using my RC PWM mux, it didn't. My indicators here weren't working. And also, I want to get the RPM value out of the ESC motor controller as part of the feedback for Ross to get the odometry out of it, and also look at the battery and the voltages and the currents and stuff. So I want to get all the information I can out of the ESC controller, and so I tried to figure out, okay, what is, if you just hard connect the receiver and the ESC motor with just a simple wire, everything works and all the telemetry comes out. But when I put it on a switch, it didn't. And so when I put a scope on it, I realized that there's some higher speed serial communication going on. So I said, okay, this is the week to crack that. And I've been trying to figure out what it is. And it's basically just half-duplex UART, which is nice.
Half-duplex what?
So on a single wire, it's a half-duplex UART at 115/200, and getting the information to and from the ESC, and so I have I've been working on a schematic, and this is just just a block diagram. So I got my microcontroller with two UARTs, RX0 or RX and TX0 and RX1 and TX1, and I have some analog switches out here. And so when it first powers up, the throttle signal that goes from the receiver to the motor controller, the ESC, just passes straight through, and so everything works. Out of the box, you can use the controller and do all the work, run its throttle. But if I open it up and say, okay, I don't want to pass it through, I want to be able to manipulate the information going to and from the ESC, and then manipulate information coming from the receiver. And so to do that, I use two more analog switches, and I haven't gotten to the point of getting this to work, but it should work. I have the bypass switch working, prototyped, but and I have prototypes for this halfway built, and so I should be able to open up the bypass, and then one piece of code would be just something real simple, just send the packets back and forth from both receivers. So packet that's coming in the receiver here that should be going to this. Oh, yeah. So we'll go from receive to transmit, but not all packets go out. Like if a packet comes from the throttle, from the receiver, the RC receiver, what am I trying to say? Oh, when I'm monitoring it, I'm going to see both the packets that I generate and the packets that I receive. So I'm working on that. And this is the bigger schematic right here for it. This is the board that's
sharing something.
Pardon?
Are you sharing something?
Oh, crap. In my mind, I was. Okay, let me share. In my mind, I was sharing, but thanks for saying something. Okay, so this is this is what I was talking about here. The little block diagram with the bypass switch and then the 2 transmit switches, so that so basically you got to wait between receive packets and then you can transmit a packet back. So that's basically the protocol, and so
Why do you do that? Like, how do you use that?
What do you mean? Let me go back to okay, so basically I want to be able to, here's my microcontroller hooked up to my Raspberry Pi through a serial port, and I can send the throttle information to my motor, and I can receive back the RPM information, which is basically the what do you call it? Oh shit! Well, the feedback. So it's the odometry, right? And I can also, from the throttle while I'm running, I'm using this as a fail-safe switch. So I have to keep the button, the switch closed, and so I can receive. I can look at the throttle information from the receiver and know when I need to release it. And I can also take the battery information from the ESC controller, the voltage, and send it back to my transmitter to get it back on here. So when I'm running it, I can monitor my battery real easy and do the fail safe.
So is that feedback your encoder ticks?
I don't have any encoders on this.
Oh, okay.
platform.
So how does it read that? Reading that feedback, how does it read it?
Right. Yeah. So I have the motor RPM, and it's a hard connection with gears to the wheel, so I should be able to tell Ross more correctly what the actual velocity is, instead of saying, "Oh, I sent it to this velocity, so I assume it's at that velocity." So now I can read the velocity of the wheels and get a tighter feedback, even though I don't have a wheel encoder. And so that's the idea of this, is to basically break it so that it's not running as a manually remote controlled car anymore, and now it runs off the computer, and I can still use the remote control to manage it like a so work in progress. And so here's the schematic. I've been looking for the right analog switches to use, and something I can easily get. It's not too expensive, and all that stuff. And the CD4066 is a quad analog switch, and so I'm going to use that for my switches that I showed on the other one. But one thing is, it likes to run at 6 volts, which is, it doesn't like to run at 3.3, should I say. It's a little sluggish because old school CMOS. I mean, it runs pretty good at 5, but I have my BEC, which is the voltage for all the peripherals of the chassis, is 6 volts. So I can run it directly off that, but I can't give my microcontroller 6 volts, So I got some little NPN transistors that I'm using to interface it to my Oh, and also the control signal at 3 volts with the 6-volt input, it's not a logic 1. So I got to convert the 3.3 to 6 volts for control signals for the switches.
That
got
that
the,
CD4000 chip family goes back to the 70s and 80s.
Yeah. But I was trying to find something I could get really easy on Amazon, and I was looking for some newer, fancier ones that
Well,
run off 3.3 that
I
are
just
modules that don't have external components, and I couldn't find one that I liked. So I said, okay, the 4066 works. But the only thing is I gotta have a little level converter basically for it. So that's the so this is my schematic. This is that RC mux, and so my throttle doesn't go through it anymore. It just runs through this circuit, and so it all works now. So that's pretty much where I'm going. Let me share a different screen here. So where's my? How do I get back? Stop presenting. I'm gonna share my Arduino screen, which has the message right now. Share screen. Huh. Doesn't let me select Arduino. That's window or screen. Interesting. Well, I'll just share the entire screen and then pull up the Arduino. Hopefully that'll cut the feedback. So can you see the Arduino now?
Yeah.
Yeah. So you can see here the I have the RX0 and RX1, and since it's in bypass mode, I get the same packet on each one. And this is the packet CD, which is basically the packet going from the receiver to the ESC. And then when I turn my receiver on, can you see my receiver?
Yeah.
Okay. So if I turn it on, the packets more interesting packets will start going through. And then you can see on the receiver that I'm getting the voltage.
Oh.
So it's my batteries are fully charged. They're about to run out, so I changed the battery right before the meeting. And then if I stop this, it seems like when I look on the scope, I can see packets colliding. So it's not so their setup I thought would do a really good job of managing the packet timing, but it does have packet collisions. It shows up on my code as a bad CRC. The CRC doesn't compute. So periodically I just get a bad CRC. Well, that's a big chunk of them there. But there's the information is pretty redundant. So might miss a throttle command that they come out at like kilohertzes. So it's highly redundant. And then this message right here, if you can see, that 40 is, I believe that's the byte that says, send me your telemetry. I'm not sure if it can tell it what telemetry to send, but then instead of a CD here, I get another packet right here, which is the 80 there, which means it's a telemetry packet. So this is some telemetry information. And right now I'm trying to figure out how to decode it. I found some stuff online to help, but it's not complete. So it's going to take some engineering. like I took this CD packet in. I believe that this one of these bytes right there is the oh, in fact, I can do it right now. Let me just continue. Is the throttle. Sometimes it freezes. So if I yeah, so you can see these bytes in this area change. Yeah. Something's going on, and my code isn't robust yet. So so I'm just going to abort this show and tell portion. Let me stop presenting. So that's where I'm at. I'm making progress slowly. Yeah. Oh, I got a good stand for it. So it's sitting over there. Where is it? Ah. Is that it? No, it's just junk on the ground. Oh, there it is. No. Where is the darn thing? Where's my robot? Oh yeah, there it is. I couldn't even see it. Yeah. So it's sitting up there. So I had to use two, since it's such a big chassis, I had to use two blocks, one for the front axle, one for the back axle. So like I said, I'm making good progress. The one I want to get the microcontroller that goes under the hood buttoned up, and then I'll put the platform piece of wood back on so I can start putting the stuff on top. So the idea right now is that make this microcontroller that goes under the hood, all that circuitry working and tested, and then I can say, okay, now that's all working. I don't have to touch it again, and I can start working on higher level stuff. That's it.
So are you using a Pico on this?
Oh yes.
Oh.
I'll bring the schematic up again. So where's my share? Share. Oh, I could have brought up the ID right there. Ah, okay. Okay, so the I've been using this format of a Pico, which is the WaveShare RP2040, and it's really small. It's a nice, real small package, so I can squeeze it into tight places. And so you can see here I'm using all these connections, but I haven't used these pins yet. I don't think I'm going to use these pins. I don't think I need any more functionality under the hood.
Like when I was working on my line following robot a few months ago, and I stuck an ESP12F on it, an early ESP implementation, and I needed to read a bunch of analog signals, and it's only got one analog input. So I froze it with a CMOS 4051, which worked really well.
Yeah.
It's a 1 of 8 analog switch. So.
Yeah.
And I ran it at 3.3 volts and had no problems with it.
Right. Yeah. So basically I'm using the two UARTs on these pins down here, and the two hardware UARTs. I could, if I had to do more UARTs, I can always use the PIO. But I use the PIO for the PWM encoding and decoding, like for the shift signal and the steering signal. That's still PO. That's still PCM that I can create to control the steering on the robot and the shift, high and low gear shift. So yeah, it's a RP2040 Pico type processor, but in a different format.
Are you programming it in C or in Python?
C.
Okay.
Oh yeah. I always program my microcontrollers in C.
Okay.
And And I try to do as much Python on the Raspberry Pi for ROS that I can. Sometimes you have to do C because Python isn't there yet. And then sometimes if you're doing something custom, you do a C just to get more performance. But on the microcontroller, I always do compiled C. So, yeah.
Have you been able to get VNC working from a different computer onto your Ubuntu 2404 Raspberry Pi?
Yes.
Okay.
And the only trick I could find is to run, is to load and run the VNC, what's it called? Yeah, let me close this off. Which one was it? I have instructions on here. This is how to do it. I think it's like VNC X11 VNC, and it launches a server, and then you can use any VNC viewer. And I couldn't get anything else to run on Ubuntu 2404. And this one popped up in some of the Google searches and it works. I said, okay, got a solution. Yeah.
Hello. I don't know where she is. I can't find her.
I
wonder
Here.
Wow, Kareem's got a fire going.
Oh, wow.
Perfect night for it. Just burning yard debris on a cowboy grill.
Yeah, the name of the program is X11 VNC.
Okay.
Where's the chat?
All right, thanks. I'm just curious. I couldn't get it to work, but I'm thinking it might have been my firewall issue again.
I couldn't get anything to work until I did that one. It seems a little primitive, but it actually works. So, yeah.
I've had more luck with Tiger VNC.
With which one?
Tiger VNC.
Yeah, that didn't work for me either. For some reason, for the 2404. But you got it working on 2404?
I gotta check. I'm using that on my Pi 5, which I'm not using for robot stuff, and I forgot.
Pi 5 only runs 2404 or 25.
Actually, my Pi 5 is running the Raspberry Pi OS.
Oh yeah, and then Docker, yeah.
No, I don't. Again, I don't use Ubuntu on the 5. I run Ubuntu on my Pi 4. On my Pi 4, I think even there, I'm pretty sure I was using Tiger VNC.
Yeah, on my Pi 5 using Raspberry OS, Real VNC and Tiger VNC seems to work fine. But under Ubuntu, I couldn't get those to work. With the Ubuntu desktop. But the solution was X11 VNC.
Yeah, on my robot, I don't use it. I don't have the GUI. At least on my current setup, when I switched to ROS 2 and whatever version of Ubuntu that is, I forgot already. I'm just running Ubuntu server. I'm not even running any desktop components of Ubuntu. So just to save on the resources.
Yeah. I wanted to do that on my Pi 5, but I decided to run the desktop to get more graphical information. I would like to undo it and make sure I can do all the graphic debugging on my laptop, but that hasn't been working so far. So
yeah, that's what I've been doing. Arvis runs on my laptop.
Right. I don't want to do that during competition or anything. That would just if I'm using the Navigator stack. I'll make sure I never turn on RViz. Yeah.
Paul, how has no machine been working for you?
But
How has no machine been working for you, Paul?
no machine worked great. Just worked great.
What's
It's,
no machine?
If you're ever hard up and having problems with different kinds of remote access, I found no machine is just about the most solid thing that works for me across all of the different environments that I'm in. And it's not open source, but it's free, and it's just rock solid for me. So
Okay, I have an update if Mike, you're done.
Yeah, I'm done.
So a couple of weeks ago, I started moving from RAWS 1 to RAWS 2. I had to like take a break, so I haven't worked on it in a couple of weeks now. But here's one observation. It's like everything seems to be much slower. I mean, it's for a given use case of some data getting published at some rate and 2 subscribers, it like takes at least twice as much CPU RAWS 2 than it used to take on the RAWS 1. So I don't know if anyone else, Paul, if you have noticed that, but it's between, and some of that is because RAWS 2 runs only on the 64-bit OS. I know that carries some overhead, but I'm still collecting some data points to see exactly, but I could immediately tell, wow, this is taking so much more CPU than what it used to take on just RAWS 1 on 32-bit Ubuntu. So I'm looking into that, and maybe it's fine in the end. You know, I have 4 cores on the Pi 4, but still, it just seemed to be, you know, again, it looks like it's taking twice as much CPU. So.
Yeah, I don't have a sense for that.
Where is she?
I think she was under the bed because she came down the hall.
Okay.
Well, I've never touched Ross 1, so I just know that Ross is a pig.
Yeah, for sure. I mean, it's not like RAWS 1 was super fast, and especially since I'm doing things in Python, but it's definitely, again, like I said, about 2x the CPU usage.
Are you talking about Python apps specifically here, Chris?
Well, yeah, because that's all my stuff is in Python.
Oh yeah. Python apps have a serious issue. And which are you on Jazzy or a different release?
Whatever you're supposed to use with RAWS 2. Yeah, so Jazzy is the version of RAWS 2, right? Yes, that's the one I'm on.
Okay. Because there's a known issue with Python running extremely slowly on RAWS 2. It's a poor implementation apparently, and I think they did something to speed it up. But I was seeing things. Now you said it was Python. That triggered the memory. And whereas the C++ listener to something like odometry would consume just fractions of the CPU, few percent at most. I was seeing Python nodes take like 20 to even 40% of a CPU of a core, just subscribing to odometry at like 50 hertz. So yeah, there are some serious Python issues.
Okay,
still.
That's good to know. I need to then Google that. Yeah.
Yeah, I read that they'd improved it some on Jazzy, but from what I understand, it was a weak implementation.
Well, a little off subject, or not off subject, but last year when I tried to move to Ubuntu 2404 and to get to like a Jazzy or something, I realized that the Python library didn't have PySerial, and this year it does. So I was able to go forward. So
I remember that.
It just dropped me in my tracks.
Yeah.
So I said, okay, I'll do
You
everything.
were a bit ahead of the curve then. You were trying to move to 2404 just a few months after it had been released. And that's really a bit earlier than you ought to move to a new ROS release. You got to wait for the rest of the ecosystem to catch up.
Yeah. So I was happy that it works again a year later. Yeah.
Yeah.
I'm ready to move on.
This is the right time to be on Jazzy. You want to be on Jazzy now. Well, we can switch to open mic. I'm going to just drop off here pretty shortly and go over to the ROS discussion group. But feel free.
Well, I've got one little item that I'll show you. First, there's a little demonstration video that might be of some interest. Let's see how this works. This one. You can see that funny looking machine there. First of all, this came to my attention today in the local news because a combination of Pollution Probe and the Ontario government have obtained one of these beach cleaning robots in order to experiment with it on the beaches at various provincial parks that have lakes in them throughout the province. So they've acquired one of these for the summer, and they're testing it at half a dozen different parks, and they started a couple of days ago. For Pat, they started up at Lake Simcoe. Let me just start this. I'm not going to turn on.
This does not look like Ontario.
Well, this is the promo video from the manufacturing company. So no, we don't have those palm trees in Ontario. The video that was on the local TV channel was really bad. So I'm not going to show you that one. It was, from a robot point of view, it was terrible. It was all about the environment and pollution probe. But let me show you this. This robot claims to be not only remote controlled, you can see his remote control in his hand, but also autonomous and all electric, and it has a solar panel on it to recharge itself. Let me just show you some of this. I'm not going to turn on the, well, let me see what happens. You hear that? Yeah.
Can't hear anything, but I see it.
Sound is not coming through.
Oh, okay. I didn't know if it would or not.
But you can just give us voiceover.
All right. They report this thing as this version he's showing ran for 3 hours. The version they're using now in Ontario will run for 8 hours on a single battery charge. I haven't seen anything that tells me exactly what its autonomous capabilities are. Let me just stop sharing this for now. I haven't seen anything that talks about what their autonomous capabilities are, but the marketing on the manufacturer's website states that it's autonomous as well. Looks like a very interesting development if it's truly autonomous from a beach cleanup point of view. They were focusing a lot on ensuring that it was extremely capable at actually picking everything up from the sand that you tell it to drive over top of. Kind of pricey. They're about $50,000 each. But it looks like an interesting idea. So that's yet another example of a real world robot.
But that's pretty cool. Yeah.
was going to say, whoever empties the bin gets to rummage through all the lost jewelry and, expensive watches. And,
The local TV's
Seashells.
blurb on this thing, the pollution probe environmental people, their big deal was, we're collecting everything that we collect out of the beach because we want to find out what people are throwing away. Yeah, but yeah, maybe you'll make some money too.
there you go. Give it back to whoever bought it. Yeah, imagine be curious to look and see how it's doing after like a year of use, because I don't know if are there any parks that are saltwater or just freshwater lakes.
Yeah, they're all freshwater in Ontario.
Yeah, still those sands pretty corrosive. I mean, it gets into everything. And
Part of pollution probes involvement is they're handling some of the marketing, because part of what they want to do is raise awareness with people who use the beaches about all the garbage that they leave in the sand.
Yep.
She says, plastic, all kinds of plastic bottles, wrappers, cigarette butts.
Mm-hmm.
Just, they want you to please stop putting this in the sand because it all goes in the water.
Yeah, and the fish and stuff eat it. And doesn't make them. It makes them sick. Yeah.
Well, that's all I had.
All right.
Okay,
All right.
folks, night.
Well, it was good. Thank you. Bye.